This video is the start of a new series where I'm going to be making some projects that require more different parts like electronics, and this is in fact the first project that I have made and that this video is about. It's a memory game. You have to remember where you see the lights light up. Right, so level 1 is just 3, and I remember it was this red, blue, red smiley face because I got it right. Oh shoot, I didn't see that. Okay, now I'll just 1, 2, 3, 4. Oh no, I didn't get that right. And then it tells me what level I got to. So each next level you have to remember one more in a random sequence, and then you have to type in the sequence, and that's basically the game. And this is the little games machine. So this is what we'll be making in this project. The first thing I'm going to do is show you about the code that makes this program work, and I'm going to emphasize some of the important features. In this case is about buttons, and then I'm going to show you how I made the project, which is sitting here beside me. Firstly, you can see the code on the screen. If I zoom in, that at the beginning we initialize a load of variables. A couple of the peculiar things that we do here are we create 2 empty arrays, and something that's peculiar is I set button A, B, C, and D to 1, 2, 3, and 4. So to add a number, in this case 2, which is equivalent to button B, I have to create a variable which it has the value of 2, and in this case is called button B. And then I put that in that block there, and everything works fine. Well, after we've done that, we go into the forever loop. The game state is indeed equal to 0, and we digitally write pin P5 to 1 and P11 to 1. That is because of the special thing in this project, which is about buttons. A button is where you have a wire, and that wire is essentially broken, so there's no electrical connection. When you press the button, you somehow, in different ways, connect the wire together. But how does the microbit know that you've connected the wire together? Well, it has to detect a change in voltage. Voltage is something like the levels in a building. If you start with the ground floor, the first, second, and third floor. Now, the microbit works with 3 volts, and that's what we can call a digital high, or a 1, or true as a value. And the opposite of that is ground, which we can think of as 0 volts. Here it says 3 volts, and we can think of ground as 0 volts. And that's something like a digital low, or 0, or false, are different ways that we can represent that. Now, buttons, if we want to connect pin 0 to a button, then pin 0 is normally at 0 volts, which, like in your building, is on the ground floor. So if you want the microbit to detect a change, you need to connect it to a different voltage. And since we're just working digitally here, it makes sense not to try and go to like 1 or 2 volts, which I guess we could, but it just makes sense to connect it to 3 volts at the digital high. So we need to connect pins P0 and P1 to 3 volts through the button. And then when the button is pressed, the voltage goes from the ground floor, essentially, up to the 3rd floor. Buttons A and B are different. They actually start at 3 volts. They start high. To detect a change, we need to send that lift down to the ground floor. And so we connect buttons A and B to the ground pin. But we don't want to use these 2 buttons specifically, physically, because as you can see in the final product, they're just not really in the right place, and they're not really big, fancy, nice buttons like these little beauties here. So how can we do that? Well, these buttons are actually connected to 2 pins in this strip of pins at the bottom. Firstly, pin 5, which is between pin 0 and 1, and pin 11, which is between pin 1 and 2. And so that is why, if you look at the program here, we are just making sure that those pins are being kept high, because when I was working on this program, I was having problems. Somehow the voltage was in the middle, or it was confusing the microbits sometimes, and so I just have to make sure that the voltage is always high or low. Then we go to this starting animation, and the game just waits at that time. When you press A, if you are in that starting animation, level is set to 1 and game state is changed to 1, at which point we call the function run game. In this function, it will set the total number of presses that you need to do to the level plus 2. For level 1, that will be 3 presses. And then it will use this loop to create the random sequence. And for each of the 3 values that it needs to choose, it's going to pick a random number between 1 and 4. Then it will set index 4 is a random name, to 0. And we use a while loop. And while index 4 is less than the total number to press minus 1, in loops, in computing, we don't start counting on 1, we start counting at 0. And then it will essentially display the quarter of the screen that it wants you to see, and then it will clear the screen. After it's displayed all of those, it will call the get ready animation, and then it will set the game state to 2. So the next time we go through the forever loop, we're in game state 2. We want to call this next function read player sequence. So if we go into this, we can see that the first thing that happens is it says if the length of the player sequence is equal to the total number to press, then the player's finished their part of the game. But if it hasn't, then the player hasn't pressed the button enough times yet. So listen for what buttons the player does press. We give the player a little bit of feedback. We add that value to the player sequence array. Then we just keep on going. Then we set the game state to 3, and we have these two functions. So firstly, check sequences are the same. It will set the value win to 1, and then it will loop through the 2 arrays, comparing each value. So it'll compare the values at address 0, and then address 1, and then address 2 for the first level, because there are 3 values. And if they're all the same, nothing will happen. But if they are not equal, as you can see here, then win will be set to 0. When that's finished, we get the next function, check pass level. And check pass level simply reads if win is equal to 1. If it's not equal to 1, it's equal to 0, so it'll do the second part. If you don't win, it gives you a sad face, half a second to think about it, and then it resets the program, essentially, and shows you your score. Now, it doesn't reset the level back down to 1, because that always happens when you press the A button. If you did win, then it gives you a smiley face, and it gives you half a second to feel good about yourself. It increases the level, it empties out the arrays again, and it sets the game state back to 1. So 1 is essentially where the game starts, and then the arrays are created and things like that. So there we go. That's how the code essentially works for this program. Let's start looking at what it was like to make this little beauty. We have the microbit here, and we also have a battery pack, which is quite useful to power it without the need for sticking it into a computer. That easily attaches it's called like an RJ45 socket or something like that. And we also have 4 buttons. The buttons all have different colored tops, and they come in 2 parts. I've started making a net, which is the 2D version. We've got the top and the bottom, and then we got 2 sides, and then we've got the other 2 sides here. And I'm going to cut this out with a Stanley knife, and I've indicated where the LED screen should come through, and I've also put some marks for where the buttons are going to be. I've cut out the net and I've spiked it to get the holes ready. And something that I just worked out that works quite well, that I was quite happy with, is I just have this tiny little handheld mini grinder, and the little grinding tool actually works well for just making these holes a little bit bigger without making them a mess by just pushing pencils through or something. At the moment I push the soldering iron through and it is a bit messy, so you can see not very powerful. Let's try that again. I feel like a dentist. I should have been a dentist. I bet they have better equipment. Ah, no! Be more careful. Is he still under? Here is the complete net. Right, now I've got to try and fold it. I think about maybe a single layer card next time I'm trying to make something. I just wanted something durable. I'm singing in the rain. You've got to entertain yourself while you're doing these things. You know, with the ruler, it's okay. The tabs. I'm going to do the tabs. The tabs are so small. I'm folding my main cardboard structure. Oh yeah. Oh yeah. That's right. Slightly satisfying. Gratification. Oh, look at that. That's not bad. That's not bad. And it's a lot stronger than I thought it was actually going to be. Right. Happy with that. Wow. So happy when I see it, actually. I feel like it could work. And not be a mess. Great. Right, now we've got to do the electronics. Quite simple in this case. What we need to do is we need to put some wires on here. I'm going to be using pin 0, pin 1, pin 5, which is somewhere in here, I'll have to check it out, and pin 11, which is somewhere in here, I'm going to have to check that out as well. And I'm going to connect 2 of those to ground and 2 of those to 3 volts. I haven't used the soldering iron yet, so I'm just going to tin it a bit, as they say. I changed the tip for a really thin one, and I'm going to try and attach. Oh, how do I do this? Maybe I'll get a little bit more solder. I don't think I'll need much. Heat up the wire and the pad. I think that might be it. Okay, there we go. It's easy enough to test if you have a multimeter, which way the contact should go on the buttons. Because if I put this onto the connection test, which is this one that looks like a little sound wave, when I connect I get a beep. So if I connect 2 that are already connected on the button, it will beep, which I think should be these 2. Nope. I was going to get it wrong. So, in fact, please don't check that. Okay, so in fact, the 2 that I need to connect are the 2 that are close together, like this. I need to connect 1 to high and 1 to low, effectively. And the opposite each other, I don't want to connect those because they are connected already. Right, let's get going with that then. Okay, I've now soldered it all together. I did have some trouble with this because I didn't realise that if you solder onto the back, the bottom of the big pins is not actually electrically connected to the pin. So you have to solder it to the ring or the other side. Now, I didn't know that to begin with, so I soldered it there and I tried it, and it just didn't work. And I tested the buttons, and the buttons worked, and I just used a little wire to connect the pins. So I was just trying to eliminate what was wrong, and then I noticed when I was looking at it that there seems to be a no connection on the surface between the bottom of the pins on the back and the ring, but if you turn it over there is a connection between the ring and the rest of the pin. So I did that, and now it's working fine, so I'm going to put it in the box, and then that will basically be it. Yeah, I'm going to do that now then. This is my padding space, so I'll put that, ow, gosh, that soldery stuff is spiky. Now I'm putting into place the thing that sort of helps hold the micro bit in place and also stops buttons A and B being pressed. Oh my goodness, I don't know. Just put a bit of glue on there. Stick it in place roughly. Try and get the wires out of the way. Stick the micro bit in just to make sure it's okay. Okay, we've got the micro bit in the back. We've got we got the buttons on the front. That is a huge piece of solder there. I wonder if I can do something about that. And then I've just got to fold it and stick the power in, and then hopefully it'll work. Okay, I've used a bit of glue. It's basically secure. The micro bit is not actually secured by anything apart from friction with the cardboard, but the battery pack is heavier and it's bouncing around a bit. So I'm just going to stick a bit of masking tape over it. Or 2 bits of masking tape. Yes, because this is serious. So I've put everything inside and squidged it in place, but it sometimes comes out. I've just used a bit of masking tape to hold the battery in. I'm just going to close that in there now. Turn it on, and it says 4BS, as in 4 buttons. That was the quick name for the project when I was developing it. Does its intro animation. You press a button to start, top left, top right, and then top left, top right, smiley face. I got that. That's level 1. 1, 2, 3, 4, 5, 6. Oh goodness. 1, 2, 3, 4, 5, 6, 7. No, that was not right. So in the end, I got to level 5. There we go. And that's the game! It's all finished. A little games machine, the 4 buttons project. I'm actually really happy with the cardboard and the buttons, and I think it's quite intuitive. I like the little animation here as it's waiting, but something about the start. Normally I identify my programs with a bit of very quick text when you first turn on. In this case it says 4BS. But you don't really need that when the microbit is integrated into the device that you've made. Also, you can only start the game by pressing the yellow button. Really, it should just be any button. And the text for level on a microbit screen is quite long, so I might make that a bit shorter. But overall, I'm super pleased with how this turned out. I hope you enjoy making it too if you're interested.